Welcome to Summarize Science. Today, we are looking at exotic collisions in space between things we cannot even see, boson stars and black holes. Most of us know about black holes, but boson stars are a bit more mysterious to the average person. These are hypothetical stars made entirely of dark matter, the invisible stuff that scientists believe makes up most of the universe. Researchers recently used supercomputers to simulate what happens when these two titans crash into each other head-on. Setting up these simulations is not easy because the math often causes the star to glitch or collapse too early. To fix this, the team developed a clever mathematical correction that keeps the boson star stable until the actual impact. This improvement allowed for much cleaner data on the gravitational waves that ripple out from the collision. Gravitational waves are like cosmic ripples in the fabric of space and time. By looking at these ripples, astronomers can identify what kind of objects collided millions of light years away. One fascinating discovery was that very dense boson stars can mimic black holes almost perfectly. If a boson star is compact enough, the gravitational waves it sends out look just like those from a standard black hole merger. However, there is a smoking gun that reveals the truth about what is actually hitting the black hole. Because a boson star is more like a fuzzy cloud and a black hole is a singular point, the collision is naturally lopsided. This asymmetry creates extra signals in the gravitational waves that you would not see with two identical black holes. Specifically, the researchers found unique multipole patterns that appear only in these mixed-match collisions. This means if our telescopes catch these specific vibrations, they might finally prove that boson stars exist. The simulations also provided a visual look at what happens to the matter during the event. The black hole essentially eats the boson star, accreting the dark matter as it passes through the center. Sometimes, a tiny bit of the dark matter survives the meal, forming what is called a gravitational atom around the new black hole. The team compared different mass ratios to see how the relative sizes of the objects changed the outcome. They found that if the black hole is heavier, it disrupts the star much earlier in the process. But if the boson star is the heavy one, it acts more like a solid wall that the black hole punches through. All of this work helps prepare us for the next generation of space telescopes that will listen to the sounds of the universe. To recap the important points, the researchers fixed a major technical hurdle in simulating these exotic mergers. They identified specific signals that tell us we are looking at dark matter stars rather than just black holes. They also confirmed that very compact boson stars are excellent mimickers of black holes, which makes them harder to spot. This research provides a roadmap for future astronomers looking to solve the mystery of dark matter. If they find these signals in the real world, it would change our entire understanding of what the universe is made of. The hunt for these invisible stars is just getting started. Thanks for watching Summarize Science.